What you see before you is a mixture of osmium dioxide and magnesium hydroxide. I previously tried to separate them by dissolving the magnesium hydroxide in citric acid. However, this produced a colloid of osmium dioxide so fine that my centrifuge could not spin fast enough to separate it out. So, I have to oxidize the osmium to permanently separate them. To oxidize the osmium dioxide, I will be using bleach containing a great excess of sodium hydroxide. This is to prevent it from over-oxidizing. Because the osmium is already in the +4 oxidation state, no heating is required for this reaction to occur. Immediately, a green color is noticed in solution, and this is from the presence of sodium osmate. Usually, sodium osmate solutions are red, but they can be any color depending on solvent and concentration. In hindsight, I shouldn't have added so much of the solution to it because it ended up getting really dilute. Either that, or I simply suffered losses over the separation process. The osmium dioxide wasn't all dissolving, so I decided to shake the solution around. It turned out there was a protective barrier of magnesium hydroxide preventing the rest of the osmium dioxide from dissolving. So I just decided to break this up. Even after dissolving more of the dioxide, the solution kept somehow getting lighter in color. I've seen this happen before though with sodium osmate solutions. I'm not sure why it happens, but I decided to check to see if it was oxidizing anyway. No tetroxide is being given off apparently. I then decided to add more osmium dioxide to the solution. There we go, that's a nice red color. After transferring the solution to another vial, I noticed the color once again lightened. So on a hunch, I decided to add some vodka to stabilize the solution. Now, the chemistry between higher oxidation state osmium compounds and alcohols is pretty complex. According to this awesome thesis I found, the reaction goes a bit like this. Primary alcohol reacts with sodium perosmate to produce sodium osmate with a -3 charge and an aldehyde. The reaction with water then produces straight sodium osmate. The resulting aldehydes can react with any leftover perosmates to produce osmate and a carboxylic acid. Interestingly, osmate and perosmate can react with one another to produce a trimer complex. However, I'm not working with any perosmates. I'm simply adding ethanol to an osmate, and the same equilibrium reaction seems to occur, which is really interesting. There's no reduction to any lower oxidation state, and yet the solution still turns a purple color. So either there's a rearranging of the ligands in the osmate ion, or it's producing something akin to disodium tetraethyl osmate. I'm not really sure. Now, on several occasions, as the solution lightened, I was able to make it go red again by simply swirling it. I found this very interesting and amusing. Eventually, it stopped doing this and fully committed to changing color. First going to a light peach and then eventually pink. The solution still looked a bit turbid, so I decided to centrifuge it once more, and sure enough, it removed the rest of the magnesium hydroxide. This is the final result of the solution, and it appears as though there's either a low yield or it's just really dilute.